Welcome to Live from Plato's Cave. I am Mario Veen. This is episode 41, Climate Biology with Fabian Ercan. I'm excited to share the interview with Fabian because I think it connects to some of the earlier episodes in the podcast, particularly the one with Marcia Bjornerud about timefulness and the importance of understanding the Earth's geological timescales, which also means that we need to have some more knowledge about the Earth's past in our society. And the other one, something that she also mentions, was the biogeochemical cycles, which basically means the interconnectedness between the biological aspect of our Earth, the geological aspect, and the chemical aspect. And this topic of climate biology and paleoclimatology, which means the study of the Earth's climate in the past, in the deep time of the Earth, also connects to something that climate deniers often argue, which is that the climate has always been changing. So how do we know that now this is our part, and who do we think that we as tiny humans can influence the climate? Climate biology and paleoclimatology has a very good answer to this question. But before we get to the interview and before I introduce Fabian, I have two public service announcements within Plato's Cave. So the first one is, as you may have noticed, I haven't been publishing episodes on a regular basis the past few months. And I have a good excuse because I've been working on my book about Plato's allegory of the cave. And you can order it now if you want, especially if you speak Dutch, because the publication is in Dutch. It's called Hoe Plato je uit je grot sleurt. So, How Plato Drags You Out of Your Cave. And it's a small book that provides an accessible introduction to Plato's allegory of the cave and updates it to our current time in the sense that you can work with this allegory in your everyday life. From the small things like misunderstandings between you and your friends to very big things like the climate crisis. Okay, so this book is in Dutch, but actually this podcast that you're listening to now, it started as a book. So I first wrote the book in English. Then I sold the book to a publisher, but it was a Dutch publisher. So I will first publish it in Dutch. And in the meantime, I didn't have the space in my life to work on the book. So I thought, why don't I just interview some people about their interpretation of Plato's allegory of the cave? And well, that's the podcast that you're listening to now. Anyway, if you're interested in this book, you can order the Dutch version. It's published by Uitgeverij Noordboek, and you can order it through the link in the description. I'm also still working on finding a publisher for the English version, so if you are in publishing, let me know because then I can connect you to my agent. But let's go to Fabian now. Fabian Ercan is a broadly interested climate biologist. Why I wanted to speak with him is because he doesn't shy away from broader discussions about natural sciences, philosophy, engineering, and history. And he's interested in the dimension of time because it plays an important role in biology, ecology, and climate, and in the resulting scientific field, which is called paleoecology. So let's go to Fabian. Hi, Fabian. Very excited to speak with you.
Thank you, Mario.
Many young children growing up, they're very interested in space and in, dinosaurs and other things connected to the Earth's past. And like what happened with me is that later this interest doesn't really fade, but you don't pursue it professionally. But fortunately, now I get to speak to people like you who did manage to make this into their job. So, congratulations on that, first of all.
Well, that's I consider that a nice compliment. I was no exception in liking space and dinosaurs. Of course, the early 90s dinosaur craze was fueled by Jurassic Park. And I think all toy stores and other media things that you could see as a child were full of dinosaurs back then. And all was printed with dinosaur imagery and stuff was everywhere, and for me it was really amazing. And at the same time, I was already quite interested in space exploration. So the first thing that I wanted to be was an astronaut, actually. Yeah, and then along those lines, I always appreciated science at some point. Got really into Star Trek also, and I guess my parents also really fueled these interests. So that's for me, that was like a thing you wanted to be. You wanted to be somebody that set the knowledge of humankind a few steps further. And yeah, that was a yeah path to follow. And when it was time to opt for a study for a university, then I decided that biology would be the thing for me.
And did you connect this already to the past, or because I think most biologists study the present, I guess?
Yeah, that's true. When I started with biology, I was actually quite interested in medical side of things, neurology, behaviorism, and I didn't really consider ecology or even ecology of the past yet. But as a biology student, it's really important to see all kind of aspects of biology because that is biology. It's the bigger picture. And yeah, there's so many things going on all these different scales in biology that's all interconnected. So from the smallest molecular interactions within a cell to the actual motion of the earth, biology connects all of those things and they're all intertwined. So if you study biology, doesn't matter what field you end up in, you have to know about everything in biology. So
just like philosophy.
well, I think biology is a very nice example of a very mature and good science in the sense of the art of knowing, right? So that's connected to philosophy indeed. And yeah, so it also connected to some physics, some maths, some chemistry as well. So yeah, I just decided, well, biology is the thing for me. Not because I didn't like earth sciences or chemistry or physics, but I thought it would be the best combination of all these things.
Right.
So then at some point, I actually wanted to take this course in which had a fieldwork in it, which was actually relatively special already because it was one of the only courses that had actual fieldwork in it. And then we went to the island of Terschelling.
One of the Dutch islands.
And there it struck me how everything was so connected, which I already loved. But the teachers, they showed us how the microbes in the sand were connected to the tides of the waves and the moon and the sun and everything. And that's how the island came to be in the first place because of how plants can grow in bare sand and then with these microbial layers. And then my mind was kind of blown. Wow, I want to do something with this ecology. So, and at the same time, there was also some fossil tree branches that were on the beach from the North Sea. So and then the teacher picked one up and said, okay, this is 10,000 years old. And I was like, what? And, so that really triggered the dinosaur loving child in me at that point. And my love for time and time philosophy in general was already present latently at that time, but it started growing from that point ever since. And for me, ecology doesn't exist without paleoecology or without the dimension of time. At least that's how I always explain to my students. The dimension of time is extremely important in especially ecology because things are not the way they are just because it happened to be like that. It had some sort of origin story that is still relevant to the future and to the things that you might want to calculate or want to explore in ecology itself. So from ecology, the step to paleoecology for me was kind of a logic one. And then things started rolling. Then I joined this group at Utrecht University and stayed there for roughly over a decade, actually. Then I did my bachelor thesis there and my master theses and eventually my PhD also. Came to explore a large part of paleoecological subjects. At that time, the group was actually moved from biology to physical geography. And paleoecology is a branch of science that is connecting the two. So it's kind of between ecology and physical geography. So it's fair enough to place it at either one of these departments in university. But what it meant for me or for us as a group was that there's also a lot of colleagues now that talk about sand and water and Earth history and things like that. So as an addition to this paleoecological exploration that we did, we also started to think about all these other processes that aren't necessarily biology, but are things like climate, oceanography, etc. So yeah, that's a nice addition to the whole story of becoming a climate biologist.
Yeah, that's quite an interesting path. But so your entry point was biology. Then you connected this through, okay, in order to understand biology, I have to know about time and paleo. I don't know exactly what it means. I guess it stands for something like deep time, not just the last few thousand years, but...
If I'm not mistaken, it's one of the Greek terms describing old.
Okay, old. Yeah.
Archeo is another term.
Archeo, yeah.
We see that in archaeology.
Right.
So archaeology covers the human past, things that humans left and that fossilized or that somehow are to be found. And paleoecology is everything else. So it's other living fossils, other living remains from the past, but there's no time limit on it. So you can have paleoecology from, let's say, the last century all the way back to the first signs of life on Earth. It's all paleoecology. Sometimes you say paleontology, and then you often specifically mean fossil animals. But it's kind of, I don't know, for me, those two terms are highly overlapping.
So what is then the I guess me and most people see the climate and life or biology as two kind of separate things, or maybe you can say, well, okay, the climate is like environment in which animals or humans live, and of course can understand that this environment has a huge influence on, if it gets hotter we have to adapt, if it gets colder we have to adapt. But does it also work the other way? So can you speak a little bit more in this sense? You were talking about microbes earlier, so I can understand that microbes are affected by the climate. But does it also work the other way, that microbes themselves have an effect on the climate?
The climate is more than biology itself, right? So we have living things on Earth, the plants, the trees, everything you can see that is green. Animals, of course, the fungi and all other microbes. But climate is actually the non-living nature. So we're talking about temperature, precipitation, humidity, things like wind or cloud cover. Those things you can share under climate. So seasonality also, things that have to do with the relative position of the Earth towards the sun. And those things don't really have anything to do with biological life. A dead planet can also have climate, right? So Mars, as far as we know, hosts no life currently, and Mars has a climate. It has wind, it has some sort of maybe precipitation, it has temperature, of course, it has sunshine and seasons maybe, but there's no life. So those things are separate, and it's where the interesting part for me begins is where life and climate are intertwined. So the interaction between life and climate. That's why I dubbed for myself the term climate biology, which is an existing word, but it's not a widely recognized term for the disciplines between ecology, paleontology, paleoecology, climate science, physical geography, and animal or plant physiology.
So very interdisciplinary.
It's interdisciplinary, but it's so to me that's climate biology, and it goes both ways. So biology also hugely influences climate. There's a lot of feedback mechanisms. For example, a current day example to give of this feedback is that rain falls over the Amazon forest about 6 times before it reaches the other side from the ocean to the Andes Mountains. So how does it work? Rain falls somewhere, let's say in Brazil, and then it gets re-evaporated again to the atmosphere. Then it drifts a little bit further, falls down again. And that happens about, let's say, 4, 5, 6, 7 times before it hits the Andes Mountains, precipitates there for the last time, so to speak. And then goes, for example, in the Amazon River and goes back to the sea, to the Atlantic. That's a nice example of how biology is, or how life is impacting climate in a way. Also with, if we're talking again about forests, we're talking about the reflection of the light by forest, or actually the absorption of light in this case, which hugely influences how much energy is stored on Earth. Things like the breaking of the wind by a forest, for example, or the shadow that is cast by trees. Those are relatively simple mechanisms and happen in small time scales today on Earth. But on larger time scales, these interactions also are very important because they shape the Earth. They determine how the Earth reacts in terms of these physical properties that we call climate, and interacts with biological properties. Simple thing also, the first microorganisms that produced oxygen, when first the atmosphere was void of oxygen, and then at some point there were microorganisms that did this anaerobe metabolism. You might know it if you're a sportsman or a runner, for example. Then at some points your legs go into this anaerobe metabolism, and it burns without actually using oxygen. Well, the first life forms, the first microbes that lived on Earth also did a form of this metabolism. They lived without oxygen. So they had this cellular process of converting energy to motion and to building things in their cells.
When was this?
About 2.5 billion years ago.
Yeah, so 2.5 billion years ago this happened, and before that there was no oxygen in the atmosphere.
Yeah, so at that point something evolved in some microbe that said, okay, we can now metabolize in such a way that we excrete oxygen to the atmosphere. So what happens then is that the oxygen fills the atmosphere for a certain percentage, which is today it's about 20%, if I'm not mistaken. And oxygen is a very toxic molecule. It's one of the reasons that we go old, because oxygen is so reactive. And that's also why we have this antioxidants that we need in our food to kind of protect our cells from this oxygenation. And oxygenation is a fancy word for fire. fire is a reaction with oxygen. So you can imagine that when oxygen starts filling the air, a lot of species of microbes actually died.
So these were microbes that didn't need oxygen to live?
Yeah, they didn't need oxygen. They weren't used to oxygen.
Yeah, and then other microbes produced oxygen to such an extent that the atmosphere filled with it, which meant a lot of other microbes went extinct.
Yeah, everything that couldn't handle oxygen burned off. It literally, that's the definition of burning, reaction with oxygen. So that's one of the first and one of the strongest examples of biofeedback to the climate system, or to the planetary system, I could say. And you could also say this is one of these mass extinctions that we might cover later. Although it's not covered as one of the big mass extinctions, but it's we see it as a part of our evolution, right? So in the beginning there was no oxygen, then at some point there was oxygen.
Yeah, well, that's a good example.
There's numerous examples, of course, of how biological life at some point alters things in the earth or in the geography or geology and impacting climate.
Yeah, and I guess we're witnessing one today, which, I mean, we are also alive and we're also changing the climate. Speaking of which, I told you one of the previous episodes was with Lee McIntyre on disinformation. And I'm very interested in climate disinformation. I also did an episode about flat earthers before. And one of the things I said there is that, so one of the reasons why I enjoy speaking with flat earthers, but also with climate deniers, is not so much because I want to try to convince them, but I think it's interesting to speak with people outside of your bubble. And it can also be very educational in the sense that when I spoke with flat earthers, they asked me questions that I didn't have an answer to. Why can't you see further than this? Or how does refraction work? Or so that's great, because they're like questions that I had to go and look up. So I had to go and study. And then the next time they would raise something like that, I would be able to answer them. But I would also have learned something. I don't think climate deniers today are much different from flat earthers or people who say the earth is, only 6,000 years old and yeah, all those kind of things. And so I try to approach it a little bit in the same way, although of course climate deniers have a much bigger impact. One of the questions they asked me is, I think not a question, it's an argument they make. And I think it's an interesting argument that actually could be a question to you, because I think we're beyond saying, the climate isn't changing. So I think there are not many people who deny that. But what the next thing they usually say is, yes, but the climate has always been changing. So this is nothing special. The age where we are now is nothing special because the climate has always been changing.
Well, let's start with the thing that I said earlier. A fool can ask a question that 1,000 experts cannot answer. But yeah, it's true. It's true. The climate has always been changing, right? From snowball Earth to a lava world to everything in between multiple times. And well, nowadays it seems to be proven that human influence significantly contributes to a changing climate, right? So, but there's threats to the world that do not necessarily involve climate, and there's climate-related threats that are not that are even by experts underestimated. So it's a difficult field to. What I tell my students is we have to worry about things that are not climate, but are sometimes confused with climate because they're also environmental. So I draw this distinction between environmental issues and climate issues, and I will continue on that later. So there's this climate discussion, but I think it's important for both sides of this discussion to actually listen in an honest way to the other side, because we have some so-called climate deniers that are actually not against admitting that there is a changing climate, like you said. For whatever reason, the climate might be changing. seems to be changing, and they don't deny it. But often case they are against the way that measures are being implemented in an unfair or unjust way. We have enough proof of those cases. On the other hand, we have climate experts or climate propagists who seem willing to even militantly defend their climate findings by demanding any and all climate mitigating measures, blind for unfair or unjust consequences that are sometimes proposed. And then we have parties that on paper they believe or support climate action, but in reality they don't want any climate measure to hit their own agenda. So specific examples of these are numerous, of course, cases where climate positive attitude is shown, but only implemented in the disfavor of competitors or voiceless crowds. And I really, as a climate scientist, I really want to make a strong point of actually dealing with these discussions, and not only with the scientific discussion of, yeah, but I'm right, the climate is changing and it might be caused by humans. So we need to do things that we might not want to do or might regret later or are just unfair or unjust. And I think that this is a important thing that's often missing in the in the general discussion, also in politics.
Just to make sure I understand you correctly, so there's three groups. The first group might say, yeah, okay, climate is changing, but that's always changing, and CO2 is not the main factor. And you're saying the reason is that they might not support climate measures such as, for instance, the energy transition, where we try to reduce CO2 emissions. And the second one are the group of scientists that say, well, the climate is changing, it's because of our CO2 emissions, and we have to do everything we can to reduce them at all costs. But they may be blind to issues of, you could say, climate justice, who is impacted by those measures, right? And the third one, I'm thinking of fossil fuel companies or companies that say, well, yes, climate is changing, very important, and that's why we are going to use, what is it? Hydrogas? No? Anyway, they say, well, okay, we're going to do it in a way that we can make money off it, or we don't want these other policies that we don't agree with.
Yeah, so we have this recent example of Schiphol, of course, the national airport. We finally agreed as a country to maybe do something about some emissions in this airport, and then it seems that some other parties are being financially or otherwise disadvantaged by these decisions. And then there seems to be the call like, okay, we like climate, but we don't like it that much that we want to sacrifice this. And I'm not saying that one of both is the right solution, or I don't want to make a statement on that, but it's more like it's a clear example of agenda politics, and it happens. If you try to search for it, it happens more than you realize in the first case. So it's part of the not in my backyard mentality. So people that are in favor of climate change policies or mitigation, but still only if it hits their competition or it hits some minorities that don't have a voice, or poor people maybe who don't even have the means to deal with it, So that's the last group I was trying to describe.
Yeah.
The second group that I described are maybe some of the climate scientists, my colleagues even themselves, who are not always too careful in realizing what they propose in terms of they think I'm right, the climate is changing. I've seen it in my measurements. Humans might have to do something with it. And now all and any measure that we can think of must be implemented. Some scientists that are, or some advocates, as it should say, they're not all scientists. Some advocates of extreme climate measures, to me, sometimes they come across as some anti-humanist movement sometimes. They would rather see 0 humans on Earth or something, or they do propositions that, if you think them through, amount to really harsh consequences for humans on Earth. Or they say there's too much humans on Earth, which is also a very dangerous statement if you think about it philosophically. If you say there's too much humans on Earth, you basically say, I'm one rice grain, and in this jar of rice, there's too much rice. But you're a rice grain yourself. So how can you say about other rice grains that they are too much? It's a huge philosophical problem if you state that, because who is too much? You, or people in Africa, or people in the Western world, or people in Asia? Who is too much?
And then connected with the fact that 10% of the Earth population is responsible for more than 50% of climate change, and I think the lower income 50% is responsible for just a few percent of climate change.
Exactly. So especially if those advocates say, well, there's too much people on Earth, then I try to refute this by saying, well, okay, is there 1,000 African people too much, or maybe 10 Western European people? You know, the distribution of this footprint is widely skewed. So no, I don't think that that's an argument at all. I think people should not even mention that there's too many people. As long as food is thrown away, there's also more than enough food to feed everybody, and there is a lot of food wasted. That's a fact too. So we have to put those things in line first, and we can speak about inefficiency, or we can maybe increase our food yields. That's all fine, but there's not too much people, and a person is not in a philosophical position to comment on other persons being too much. Future persons too. So that's a slippery slope that people have to realize, and that also goes in a different degree also for the climate discussion. And that's also a very political subject. So who is the Western world to suddenly come up with all kinds of climate measures while the developing world cannot develop anymore all of a sudden, because we decided to, at this point, all of a sudden wake up and say, okay, we did too much already, please back off. That's a huge philosophical problem. People often don't they underestimate how poor their position is in terms of debate. And I think, and that's a positive mindset that I have, I think a lot of climate activists, they just want to, or climate advocates, I should say, not activists, they just want to prove that they are right in the scientific way, and they are. Right? So I don't question their findings in a scientific way. I question the way that their findings are used by others. So, okay, CO2 and other greenhouse gases, they amplify the greenhouse effect. That's a fact of logic. and it's been proven many times. So, okay, we have this one thing. CO2 is influencing atmospheric greenhouse gases, which in turn keeps more energy on Earth instead of being reflected back into space. That's the core principle of human-caused climate change, right? So climate is always changing. It might even still be bouncing back from the Little Ice Age. Coincidentally, we had this Industrial Revolution, which amped the CO2 emissions and other greenhouse gases. And we have those two lines going at the same time. So we bounce back from the Little Ice Age, and we have the Industrial Revolution amplifying these emissions. And now we're overshooting in terms of temperature and greenhouse gas concentrations. Those are facts. But what are the consequences of these facts? There's some sea level rise, that's temperature influence. There's some sea level rise that is influenced by the melting of land ice, not sea ice, because sea ice is already in the sea and that doesn't influence the sea level. And that's about most of the effects that CO2 has, actually. So it's temperature in the first place and sea level rise in the second place. Of course, there's a lot of things that happen when you elevate temperature, right? So I always give this nice example of a polar bear that can survive about, what is it? Almost 50 degrees of temperature fluctuation. It can survive from plus 20 to minus whatever. Just fine. And in summer, it might be hot, and in winter, it might be cold, right? But in the tropical ecosystems, the niches are very small. So we have this case, I think it was in Australia, where at some point there was this heat wave and the tropical rainforest got 2 degrees warmer than it normally would. And then all these fox bats, you know, the huge vliegende honden, fox bats, they drop out of the trees. There's hundreds of them dead, like within few hours.
Sorry to interrupt you, but what do you mean by niches?
Niche is a biological term for someone's place and time in the multidimensional world of an ecosystem.
So it's like a part of the world where your form of life can live, thrive.
Yeah, exactly.
Yeah.
So especially in tropical ecosystems, these niches are very specific. So, for example, if you're a tropical frog, then you might be only awake during a few hours and then only hunt when the sun is at a certain position, and only mate when the moon is at a certain position. And it's all very specific, because for the next half hour, there's a completely different kind of frog that has its niche there. So the niches are very small.
Yeah, so that changes. The niche is very small. If there's a small change, it could already mean that it becomes uninhabitable for this species. But for instance, a polar bear, if it just rises, temperature rises a few degrees by itself, of course, it's a problem if it doesn't have sea ice or something to hunt on. But for the polar bear itself, that it's pretty flexible. It can adapt to different ecological circumstances.
Exactly. So, of course, I'm not saying that there is no issue for polar bears and it's all fine because they can survive. That's not what I'm saying, but I'm saying that we should be very precise and delicate in what we're calling the effects of climate change. And so the point I'm trying to get to is not to go into a discussion about the influence of climate change on polar bears, which is enormous actually, but the point I'm trying to get to is that there's so many more things going on than climate change alone.
Yeah.
And so I worked in climate science for over a decade now, actually. And when I learned about the effects of chemical pollution in the soil, which I also briefly worked in, I was actually shocked more than I ever was in climate science. So I'm not trying to understate my own field, but I think it's an even stronger message than if a climate scientist says we should worry less about climate and much more about these other things.
Yeah.
So we're talking about chemical pollution of the soil, of the atmosphere, of the oceans. Those things are much more damaging to nature, to ecology, to wildlife, to whatever, than climate ever could.
Are you then connecting to the concept of planetary boundaries, where there's 9 boundaries that have been identified, and one of them is climate, but another one is fresh water, I guess, and another one is biodiversity?
That's the same concept that I'm referring to. I don't know these 9 boundaries by heart, but there are many dimensions in which you can define, boundaries of what we're able to do with the planet.
Yeah.
And that's a very human perspective, of course, because defining boundaries implies that we want to go that far that we reach the boundaries. We actually don't. So it's a very economical and very human perspective to even phrase it like that. I'm not sure if my point of pollution, chemical pollution, is on these 9 boundaries.
There's one boundary which has to do with, I don't know the term, but it is like new elements that are being introduced in the ecosystem, like as well plastics, but all different kinds.
That's what I'm trying to get through, indeed.
So this is what future geologists will find, this layer with all these kinds of new materials in the earth that were not there before humans, before the industrial evolution even.
Yeah, so I found the 9 boundaries. Indeed, one of them, the first one is climate change. And then there's other things that do in themselves have nothing to do with climate. And I think that's a powerful message, because a lot of things are now connected to, climate this, climate that, climate crisis. We have to set everything aside for climate. Of course, we have to do everything in our power to, in a just way, in a fair way, to even mitigate the smallest things that we do, that we in terms of negative influence on the planet. But these other, let's say, these 9 boundaries, the other 8 are also very large problems. So if we tomorrow completely ban CO2 production, then still we have 8 huge problems left.
Well, it's a very interesting point to think about, because so I'm from the side of philosophy but also communication. Mm-hmm. So I focus a lot on how to communicate about this. And if you compare to a while back, when we were small children, there was the ozone layer problem. So this is a specific problem that scientists were able to say, well, there's going to be a hole in the ozone layer and it's a big problem, and this is what we need to do. Everybody got around the table and we kind of solved that. Yeah. So, but this is the way we are used to think, right? Like, what's the problem? Let's analyze it. Let's home in on the problem. What is the diagnosis and what is the treatment? And let's implement the treatment. So, so it would be one thing if we would say, well, this is what we're doing with climate, but it's more complex. So with climate, you would say, well, we have the carbon budget to have a chance to stay under 1.5 degrees, but it's almost finished. So we need to rapidly reduce emissions. But we're not even doing that. So my communication dilemma at that point is, because I know in my communication, I say climate crisis, for instance. But yes, I know that it's not just a climate crisis. It's you could say a climate and ecological crisis. Some people have called it a poly crisis. or the meta crisis even. And then you speak about biodiversity crisis, but you can also connect it to human crisis, like crisis of justice and everything like that. But my point is that if we're not even able to do this part of CO2 emissions, but this is not this, like you say, there may even be other problems that we need to worry about more. That makes it increasingly difficult. For one, because now so in these conversations with climate skeptics, the disinformation is always evolving, right? So it could be 1 week they have this talking point, another week they have another talking point. So it could be 1 week you hear a lot about, but the climate has always been changing. But one of the things I keep hearing now is like, but you just focus on CO2, and what about trees? And you're not focusing on trees. And that's pretty much, it's not exactly what you said, but it's pretty much what you've been saying. Only in those conversations, it's being used to say, well, CO2 is not the only factor. So what about deforestation? But what they mean is they mean to imply, so we shouldn't take these measures for CO2 reduction. And then the way they use it is to delay any action. But it's also a real world problem, because one example is for the energy transition is they're doing a lot of windmills in the ocean. But these are also disrupting ecosystems there.
Exactly.
That's a dilemma, right? You can say, this will help with emitting less CO2, but at the expense of another of these planetary boundaries.
Exactly. Yeah. So we have this huge focus on climate change, and I say we, but apparently there is some sort of movement that is pushing that or pulling that, and then we're making choices that are sometimes only one side of the story. So, for example, the whole electric car thing. Well, you cannot explain me how it's not a fancy toy for people that can afford it, right?
Yeah.
We don't have our energy grid ready for electric cars. We don't have our energy production ready for electric cars. Electric cars are great in itself, no comment there. But at this point, it's a very fast, very heavy thing that only wealthy people can afford with tax subsidies.
Yeah.
So where is the justice in that? So it's a lot of people, like a whole nation, is actually paying so that a few privileged people can have an electric car so they can say they're climate positive.
Yeah, exactly. And what about the majority of the world that doesn't have a car at the moment? That are not
right? There's so many things wrong with it. Why do electric cars have to be so big? If you want to be efficient, you make a very small electric car. It's the same thing with all these electric small scooters. Of course, they don't need to be electric at all because they were very efficient, like on human muscle power.
Yeah.
But that's another discussion. But
I'm starting to understand better what you said in the beginning with these three groups, because this is a good example of people who say, yes, we acknowledge that there's a climate crisis. We want to be part of the solution, so we're going to make electric cars.
Right. Yeah. And then they only see the hypothetical benefit of an electric car in terms of, yes, an electric car doesn't emit CO2. Well, congratulations. The power is emitting CO2. But it's maybe not in your area, but somewhere else. Or it might be windmills at sea, which are killing birds and aquatic life or marine life. So there's a lot of things that go all over the place with this whole discussion, and it's not even about, is CO2 actually influencing climate, yes or no? It's about something. It's about taking that fact and running away with it, making your business, making your political case, putting heavier taxes on things that pollute more or pollute in quotation marks, or having a tax benefit on things that somehow are magically free from these pollutions. So it's a very complex matter, and it's not just climate deniers versus climate advocates. That's not the discussion. It's about people who can make money or profit from the narrative, and people who are voiceless to do anything about it.
No.
And then in between, there's scientists that are stating the facts, and the facts are as they are. We have the facts as they appear from the science, the statistics, the findings. And then there's everybody who is doing something with it, or is benefiting from it, or is not benefiting from it. And I'm not against technological development, right? So even an electric car should be, well, there's early adopters, there's, then it's the mass production, then it's, so that's always the case. I'm not naive in that respect, but I think you get the point of, the difference between facts and what we're doing with the facts.
Yeah, it's interesting. Have you heard of this 3 horizons approach?
Yes.
You probably know more about it than me then.
Well, I don't know. I was recently introduced with this principle by a colleague of mine, but the idea roughly is that you have a most preferable outcome, you have the business as usual outcome, and you have some things in between.
Yeah.
And sometimes it's also good or more efficient to say, well, we're going for this middle ground option first before we can transition to the most optimal version. And this is actually part of innovation science. Sometimes you lock out options by choosing one of the other options, or you enable a new option because you choose to develop something. So
just before you go on, let me connect it to the car example, right? So how I understand it is like, so the first horizon is keeping the lights on, meaning, for instance, because gas prices are rising, the government is subsidizing it so that people who cannot afford it can drive to their work, but it doesn't really change anything. The second horizon is the electric car. So someone is doing innovation, but it's still kind of in the same paradigm. And the third one is where you actually want to get, which could be, in this case, shared mobility, reducing the amount of mobility that is necessary. And if you need it, then it is shared and everything like that. So kind of a new paradigm.
Yes, but now you're just rephrasing the paradigm that has been told to you.
Okay.
But what if there's other paradigms, such as in your story, I didn't hear anything about public transport.
Oh, that's what I mean with shared mobility.
Well, of course, but I already have a train station next to me. Bus lines are being cancelled in smaller communities at the edges of the country. So actually, that would be the preferable horizon, the true solution to this mobility problem, right?
No, exactly. That's I didn't say it right, but that's what I mean in the way that you use more public transport, you have more maybe shared cars if you need it, but you can also think about other ways, such as why do we need to go to do we need to go to a conference in the United States?
Yeah, of course, but yeah.
So it's kind of rethinking human movement, maybe even trying to live closer to home and to work closer to home and everything like that.
Would be preferable, but then there's the housing market. But let's keep it reasonable for time's sake and for practical reasons. But of course, a trip to the USA for a conference, it's a niche occurrence, right? It's just this one scientist in how many people who actually do this. But there is a lot of tourism, of course, and we have almost a human right on being where we want to be on this earth, I guess. But that's all we're getting into quicksand of discussions. That's not useful, I think. But what is useful is to define these. Well, you said three horizons or optimal cases. We should define those first. We should really, as a human community, discuss and philosophize with all of us in a fair way. What do we want to achieve and how can we get there? And if you approach it like that, then you can also keep this, your 9 boundaries, for example. What you said is there's 9 different problems, and if you solve one, the other ones are not solved. So it's very complex. Well, I say I don't agree with it all being so complex because I see a common root in all these issues, and that's human power struggles in the end. It's all of these 9 planetary boundaries, or maybe you can think of 20 more if you want. All of them are all abuse of power because there is everything for everybody. There's enough. And as long as there's people who are in position to control things, they have the power to change things, but they won't because they'll lose that power. And if you're a CEO of a big company or corporation and you want to have a prosperous future in this company, you're not going to implement changes that are going to disfavor your company or your private business or your political movement. But if these choices were more democratic, so to speak, or more for the general public to go decide in, or for scientists to have a say in, or just in general, a more fair approach to changes, then we wouldn't have these decisions that are always somehow not in favor of the public, not in favor of nature or climate, but are vastly in favor of the company that's implementing them. Do you agree with this common cause of many of these problems?
I do agree that there is a common cause. I also think that there is probably, I mean, that would be good news, right? Because if you have a common cause, then it means that instead of saying, well, there's what many people are saying is, well, okay, there are a million different problems. We need a million different strategies to do that. But then you can think about, but what is the perspective from which we approach them? And what I hear in your answer, you didn't say the word, but I think, so what people are saying also in climate movement is saying, well, we have to approach it from a climate justice perspective. We have to not just isolate these measures, but look at what effect they have, who gets to benefit from them, and everything like that. I also think it's a very big question that maybe I want to speak with you more later about. But I also want to get to the because we're speaking about the present, I want to get to the past as well.
Sure.
So let's speak about this part more later. Is that okay for you?
Yeah, that's fine. I just wanted to add that I'm not affiliated to any movement, so I'm not in on their vocabulary, so I'm not aware of the latest and the newest terms that for example, the climate movement with climate justice, for example, the words they use. I don't know. So sounds right, but
sounds right. Yeah. So my short answer to your question is yes. It is very connected to power and the way power is distributed and used, and who benefits and who doesn't benefit. And just like what you said about how you realize that biology, to understand biology, you have to look at the past. It's the same with this topic, I think.
Yeah. Okay. Well, yeah. Good to hear.
So I guess one way to segue is really to go into the science side. But one of the things that also comes up in discussions is I speak about climate crisis, or if I have the the bandwidth or the space, I say the climate and ecological crisis. And one of the reactions I get is like, yeah, but crisis is a subjective assessment. But my impression is that I use a scientific term, and that biologists, ecologists, geoscientists have a way of operationalizing this concept of crisis by looking back in the past. So, for instance, if we look at the microbes that created the oxygen in the atmosphere, I guess that could be seen as a kind of climate crisis, in the sense that the climate drastically changes in a very short amount of time.
Okay.
So that my question is like, what if do you use the term climate and ecological crisis, or how do you look at, for instance, the meteor that killed the dinosaurs and all these other events in the past?
Okay. So you're describing mass extinctions. That's where you're getting at. And crisis to me is a word to describe a situation. So if I really need to go to the toilet, but there is no toilet, then that's a crisis. Because if nothing changes, then I have a problem. Right? So that's a crisis in my vocabulary. So if you, let's say, imagine there's a 20-story building, you're standing next to it, and there's a piano falling out of the window, and you happen to stand under that piano. Is that a crisis, or how would you define it? Because if you keep standing there, it's a 20-story building, right? It's quite tall. If you keep standing there, then the piano meets your face. But if you set 3 steps to the side, then this crisis is averted. So, yeah, what is crisis? Well, I don't believe that there's a crisis, because I'm a positive-minded person, so I believe that there's ways to steer away from unavoidable problems. So, but you wanted to talk about mass extinctions in the past, where we actually had crises that couldn't be avoided or just happened. We define 5 big mass extinctions. They're called the Big Five. The one that we talked about, the oxygenation event, somehow is not in this list. I think it has to do with the definition of how life occurs on Earth at that point, but let's not get into the technicals. Big Five mass extinction. So we have the first one, the late Ordovician mass extinction. The second one, late Devonian mass extinction. Then there's the Perm-Trias, the boundary between the Permian and the Triassic mass extinction. This is the biggest one, actually. Then we have the Triassic-Jurassic mass extinction. And then the 5th one is the Cretaceous Tertiary, or the Cretaceous Paleogene. It's the same. Mass extinction, and that's famous for killing off the dinosaurs. So that's the famous Yucatan impact crater meteorite that finished off the dinosaurs. And then there's smaller events where we can recognize, okay, something happened and biodiversity collapses to such a point that we can talk about a mass extinction. So in these extinction events, you could say they're climate related, but yeah, so in my lectures, I try to distinguish between climate and, for example, things like, planetary processes like volcanism, tectonics. Actually, there was a student in one of my lectures that during the lecture, he came to the conclusion that volcanoes and earthquakes don't have anything to do with climate. I was shocked because for me that's logic and it should be. But then I realized that maybe in the general public, there might be a lot of people that see a climate eruption on TV and then they think, I say the volcanic eruption on TV. Yeah, so there we go already. A volcanic eruption on TV, and then they think, it's the climate is going to shit. Now we have a new climate thing going on, but it has nothing to do with climate, nothing to do with humans. It just happens that's the planet is doing that. That's something related to completely different mechanisms.
But you mean it's not caused by anything in the climate? But
it's not caused by climate. It does influence.
I think one of these mass extinction events were triggered by volcanic eruptions, if I'm correct. So my only reference is Life on Our Planet, the Netflix documentary.
Yeah, the new one, right? Yeah. The funny thing is that when this documentary came out, it's about, I think, 3 weeks ago or a month ago, they came out right after I gave this climate biology lecture. And as I watched the documentary, I was like, they copied my lecture. This is, of course, it's a huge field of science and many of these lectures are given all over the world. But because of the timing, So I was like, okay, now I can say to my students, like, if you like my lecture, go watch this documentary, right? So it basically covered all of the components so they did a really good job, I think. So
because that's the challenge, right? In a lecture, but also in a documentary, is how do you tell the story in a limited amount of time? And I guess the documentary follows this pattern of the mass extinctions, but also traces so for instance, it jumps back and forth in time as well by connecting, for instance, the life forms that came up after mass extinction to the ones that we can see now, like the mammals or the birds.
They did a really good job in also bringing it to life, also visually.
So is this what you do? Is this an approach you take in your lectures as well?
Basically, yes. The storyline is a bit different, of course, but the storyline I mostly use is to differentiate between climate and other planetary processes. And then I go through the lines of geological history and I say, okay, what are the things that influence climate? And then I come across tectonics, volcanism, the way continents are situated on the Earth, the shape of the continents. For example, if they're all situated at the tropics, then it might be warmer, or if they're all in the Arctic regions, might be colder. If it's one big island, then the inlands might be dry because of their deserts. If there's a lot of islands, then there might be wetter. So that hugely influences the evolution of life on Earth. So climate, evolution, biodiversity, ecology, they're all intertwined. So that's what makes storytelling so great in this regard, that you can do a lot of nice things back and forth through time, drawing these parallels. And so the motions of the Earth around the sun and the position of the Earth around the sun, things like that. That's great. It's a fun lecture to have, and it's very important for biologists, but also for other scientists, I guess, to be aware of.
So I guess the big question is, so we've had these 5 major extinction events in the Earth's past. How do you relate them to where we are now? Are we in the 6th major extinction event? Is that something that we can say at all? Because for these other ones, we have the privilege of hindsight, of course, and now we're there. And there are also many different factors like technology and other factors that are present. So I wonder how do you relate these 5 extinction events to our present time?
So one of the main definitions of these mass extinctions is the loss of more than 2/3 of life in terms of biodiversity.
So in terms of species and not in terms of individual animals.
Yeah, so let's say you have 1,000 species on Earth. It's an imaginary number. And let's say after this event, you only find about 300 back, like kinds of species or family lines. That's a safer way to describe it in terms of deep time. So you had 1,000 family lines of species in the biological sense, and then after you can still recognize 300 of them. Then 2/3 of your biodiversity is gone. And that's the extinction event, the mass extinction event. And of course, it is triggered by something catastrophic in a relatively short amount of time. So we're thinking about millions of years in terms of time scales. We know that the end of the dinosaurs on the end of the Cretaceous was caused by this massive asteroid hitting the Earth. That probably only lasted the whole thing. It was one catastrophic explosion, all sorts of simultaneous effects. Those effects happened within a matter of hours, days, weeks, months, and eventually 1 or 2 years without sufficient sunshine. So
because of all the dust in the atmosphere.
Yeah, so because of the cataclysmic dust and everything going on. But there's also effects that happened immediately, of course. But let's say we're talking about 2 years event, right? So we can agree on 2 years. But still, that's a very short moment in geological time. The other mass extinctions, they are probably, they have been lasting for maybe 10,000 of years. So we have these, some of the mass extinctions were caused by volcanisms, and others were caused by global cooling. But we have no evidence that it happened overnight. Some of these processes are relatively slow. So to answer your question, how are we dealing today with our biodiversity in terms of mass extinction? Of course, we don't have a crystal ball, so we cannot know what will happen. But humans, in a general sense, they have been causing extinctions already quite a bit. Because if you look at humans, they left Africa at some point, and everywhere they went after exiting Africa, the megafauna dies. And megafauna is a definition for large, especially mammals. So
bisons and elephants.
Yeah, so elephants outside of Africa, because the elephants inside of Africa and India, we have to take that into account. They were used to humans, to the funny monkeys that we are. They knew, okay, we have to watch out for this other animal. But the animals outside of Africa, they were not used to us. So when we went to Europe and Asia, we killed the mammoths, right? So when we reached the Americas, we killed the giant sloths, for example.
So you're saying one factor in that was that they did not maybe see us as predators.
That's a hypothesis. Yes,
that's interesting. It reminds me of in the documentary. I always forget the name, but there was after one of these extinction events, you had this mammal, I think, that was
the little bald one, right?
Yeah.
I don't know the name of this one, but
they were thriving on Earth because they were one of the few species that survived the catastrophe. So they were just like there for a long time. But then you got this predator, and that's one of the highlights of the documentary, because you see this predator that emerged, but they were not evolutionarily used to see it as a predator. So basically, it was just what you say, like, could just eat whatever they wanted. And it was interesting for me in the documentary because first I thought like, oh, this first species of mammals, that's like the humans, because we are thriving. We don't have a natural enemy except ourselves, maybe. But then I thought, no, of course we are the predator.
Plot twist, plot twist. Yeah. So evolution is an arms race, and it happens all the time that a predator species is surprising a prey species by a new way of attacking or something. You can imagine in human war if the first person who ever saw a mounted horse running towards them with a guy on top of it, um, what must he have thought, right? Like, what is happening now? We're going to lose this. And that's what happens in the documentary as well. It just doesn't recognize the danger.
Homo sapiens from Africa, everywhere they migrated, they caused extinction of large animals.
Yes. Yeah. That happens. So the extinction of megafauna outside of Africa is hypothesized to be because of humans. Yeah. So if you look at the records, you see the first signs of charcoal, so fire. Then you also see the disappearance of these megafauna fossils. Yeah.
So what does that tell us so this continued, obviously, about whether we are in an extinction event like one of the big five ones or not?
I think the way to think about it is also the reversibility and the changes of the context outside of our doing.
Yeah.
What I'm trying to get at is it's all about definitions, and then you can say, okay, what do we win by defining this? We should, in Christianity, we have this saying about stewardship of the earth, right?
Mm-hmm.
I think that goes for our guidance, should be something like stewardship of the earth. Why do we have the right to erase a lineage of biological species? We are also a lineage of biological species. We should be proud to preserve our very distant cousins, be it plants or animals or whatever. Not only for our personal gain, but also just for the philosophical fact that we're only one planet, as far as we know. There might be some very techno optimist people that think that we're going to Mars sometime soon. Well, there's no life on Mars, so then we'll be the only ones. And there's so much to learn from the rest of life on Earth. Maybe some medicine to discover, or otherwise, the potential of life in this universe to survive other than humans lies in the rest of the biodiversity. So we have this kind of obligation to take care of our younger siblings, so to speak. So every species, every lineage lost, it's a huge shame for us to have witnessed and caused, I think. So if we define it as a mass extinction or whatever, that's not even relevant. We shouldn't do anything that harms nature in a general sense.
But I guess the way it matters, and not just about extinction, but also about climate change and change of ecological systems, is that we've had a period of relative stability in which human civilization came up. So naturally, because that's all that we remember, we think, well, this is just the way the world is. But now, as far as I can tell from what I've read and people I've spoken with, is that this is changing. So we get instability in many ways, but this instability is also kind of, for us it's new, but it's common in the Earth's past. So actually 10,000 years or something more of stability, relative stability, that was more an exception, but this stability is now over. And then, of course, I want to know, well, is this something that's going to to go on and get worse from our perspective, right? And what does that look like? And is there anything you can say about that from looking at the past, or is this also unknown territory from your perspective?
So there's a lot to break down there, because first you say there's has been a lot of stability over the last 10,000 years, which is the Holocene. Yes, there has been relative stability. There have been few cataclysmic events. That's true, but at the same time, it's not really true, because the things we're experiencing now, it's not necessarily unheard of in the last 10,000 years. Of course, maybe the rise in CO2 is caused by our modern system, of course, but for example, now there's floodings in northern France and western Flanders. But at some point in the 2,000 years ago, those areas were also marshy and with a lot of water going on. So we've been conquering these things. That's what makes us a human civilization. We've been, with technology, fighting to get this stability going on. That's the whole point. That's this fighting against the forces of nature has been defining our struggle as a human species to establish ourselves in the way we have now. So we've been establishing our civilizations, but never forget that also civilizations have their mass extinction, right? So the Bronze Age collapse at the end of the Bronze Age, that was also a mass extinction, a huge crisis. Civilization collapsed from being literate and stratified with all kinds of hierarchy and communication. And then all of a sudden it collapsed, possibly due to climatic events, certainly due to a combination of climatic events and political events. And after that, literacy was almost vanished completely. And then we had to build up again after the Bronze Age. So then we are slowly progressing into the Iron Age. So we have been experiencing these kind of ups and downs in human civilizations anyway. We didn't have a stable 10,000 years to evolve. We are constantly in battle with nature. Nature sometimes wins. We in the Netherlands are famous for conquering parts of the sea, of course. So yeah, there's a lot of examples. So we have the watersnoodramp. We created Flevoland. So there's some wins, there's some losses. This is always being the case. Also, if you take it completely separate from climate change. So what we're doing now, yeah, we're getting aware of it. That's the main point. And the funny thing is, we're the first species that's aware of their damage we're doing to the earth and other life. So that gives us a moral obligation to take care of it. Because if you are aware of your faults, you have a moral obligation to deal with it and to do something about it. And that's where the stewardship also comes into play again. So that would be my answer.
Yeah, that's interesting. I have to think about it more as well. So yeah, actually you were referring to 2,000 years ago, and Plato wrote this allegory about 2,400 years ago. So even since then, there has been some fluctuations and instability and everything like that, right?
Certainly, yeah.
How do you read Plato's allegory of the cave?
So we step back from general climate science, I guess. But the allegory of the cave is an intriguing one because it has so many valid interpretations. One way I look at the allegory is the perspective of reality through this inescapable lens of your own consciousness. That's for me, it's the core interpretation. Is reality electromagnetism hitting your retina, or is it electrochemical signals reaching your brain? What's reality? Additionally, you could regard the allegory as a personal view of the social world, of our human understanding of the world. We are introduced to truths like mainly through media like books, internet, or education, or social interactions. That's a fixed lens you have. And finally, for me, the allegory can also be regarded as the limit of science and philosophy. Truths are true until proven otherwise. I could tell you a window produces light, but that would be true until you take a step outside to see that the sun or a street lantern actually are the sources of light. So we're constantly breaking down the things that we know in favor of new insights. And for me, that's also a part of the allegory. When is something the real world?
So that also means that in your field, it could be that we get a completely different perspective on the state of science now.
Well, that's true. That's always true for all science. But the climate of the past is anchored at some very hard to refute observations, of course. So if you find a crocodile fossil, a palm tree fossil in the Arctic region, it means at some point some sort of tropical conditions prevailed there, right?
Mm-hmm.
So as with all science, from a network of clues and hints, fact upon fact can be derived, forming a pyramid of knowledge, at which each step is forming the next stone, pushing knowledge pyramid higher and higher. And for me, that part stands solid, right? So you're building something that's made on a solid base of facts. So if a puzzle is only you lay a puzzle out on your table and it's only 10% of the pieces are there, then it's easy to draw some lines between the pieces. But obviously the chance of error is very high. It's very probable that the lines you draw are not the true lines in the complete picture. So we have to be careful not to draw conclusions from what we see, but the conclusions that are universally true with the data at hand, whilst also admitting that some context might shed different light on the facts in the future. So we can certainly be sure in the things that we can be right about, but we also should leave a door open for new facts. So, for example, the crocodiles and palm trees that I just said in the Arctic. What at that point, if you knew that the area of land that you were investigating wasn't in the Arctic back then, but it shifted from the equator, for example, then you know that the Arctic wasn't warm, but actually the piece of land used to be in the equator, right? So it's a hugely oversimplified and exaggerated example, of course, but you get the point of new facts completely changing your paradigm, your world at that point. An actual example might be that at first they proposed many subspecies of Triceratops, the dinosaur with the 3 horns. So paleontologists, they found all kinds of Triceratops shapes and sizes, and they proposed, okay, we have 20 subspecies of Triceratops. Well, at one point, they found out that the different skulls actually belonged to different phases of Triceratops growing up to adult life. So at first they had 20 subspecies of Triceratops, and then at some point you have like just the way a Triceratops grows from a small baby Triceratops to a large adult with different size of horns and different shapes of their skull.
So this is an example which I can easily imagine, because you find a fossil or pieces of the fossil of a dinosaur and you can put it together and that's, oh, this is what the animal looked like. But then how does that work for the climate? Because if I want to know what was the climate like 2 billion years ago, oxygen, everything are right gases in the atmosphere. So how can you, because this is your field as well, right? Like you try to get a sense of not just, I'm just saying randomly 2 billion years ago, but let's say I want to know which animals lived there, which plants lived there, where the land masses were. Okay, I can imagine that, but how do you get information about the climate? Is that the same? Yeah, same degree of certainty, or is that a different ballgame?
It's the same, but it takes place in a way that that maybe it's not too visible for non-geologists, because you have all these geochemical processes in rocks, in sand, in the oceans, for example. And some of these chemical compounds can only be formed under certain conditions, right? So that's a oversimplification, but that's the core principle of it. So let's say we have a certain crystal you find in your rock, these beautiful all sorts of crystals, and those crystals, they are known because of modern chemistry to be only able to form under certain humidity, temperature, salinity, acidity, pressure, and all these things combined, they give a relatively solid image of under what conditions they have formed at that time. So it doesn't matter if it's 2 billion years or 2 million years or 2,000 years. Those geochemistry based proxies are quite certain. And of course, there's sometimes, this case of, it was formed not 2 million years ago, but halfway because of certain processes, So there's always this Cluedo game or this CSI game going on of what clues do you link to each other? But that's the short answer, I guess. Yeah. So it's the same as dinosaur fossils, but it's a little bit smaller.
Yeah, and you did your PhD on leaves as well, right? Like on ancient leaves.
Yes, birch leaves. Yeah.
What did you find out about leaves? How do you say that? Paleo leaves? I don't know if that's a word.
Paleo leaves.
But ancient leaves, I guess.
Ancient leaves is a very nice word to describe it. That sounds poetic to me. So we often use the term subfossil because they're not mineralized yet.
Yeah.
But they're still they're very well preserved for 10,000s of years sometimes.
So the actual leaf material is still there.
For the leaves that I looked at during my PhD to solve questions about Arctic climate change, those were subfossil leaves. Yeah. So there's also numerous cases of fossil leaves where it's mineralized, but technically my leaves were subfossil. I still use the word fossil leaves because that's a subcategory, but technically it's subfossils. Anyway, so I looked at hundreds of leaves, somewhere relatively young from herbarium actually, but most were actually from peat deposits. So it folds open like a book, the peat, it's layer upon layer. Each year forms a new layer of peat, and then some leaves fall into the peat bog. And if you take a drilling core, you take a piece of the peat, and then you open it like a book, and then there's leaves that are preserved as if it was the leaf from last autumn. And then you can put it under the microscope, see the cells of the leaf. And from these cells, I could calculate the temperature of that year, because the leaf is actually formed in the year it also falls, right? So it's one leaf per year, of course. And then in the cells, I could calculate from the size of the cell, from the shape of the cell specifically, the temperature. And I tested that before with by using experiments in Greenland, in Finland, and in Poland to check how these leaves react to different kinds of temperatures. So there's some temperature experiments going on. And then I could make a mathematical model where I calculated, okay, so this shape means this kind of temperature, and that shape means that kind of temperature. And then you have your paleothermometer, so to speak, and then you can take new fossil leaves and say, okay, so this probably has been this kind of temperature, and then you cross-reference that with other studies that have found tree rings or pollen or fossilized insect remains that are also, this pyramid of knowledge that I earlier described. You're building on this web of clues, of facts that together make this image of the past, this paleo climate, this ecological reconstruction that you have. And that's really nice to do, to find these leaves, to hold them in your hand, and to actually imagine the ecology, the surroundings, the environment of thousands of years ago.
I have two. Do you have time for two questions?
Yeah, sure.
Okay, great. So first one is, I wonder if, because there are all these different ways to gather information about a certain time period in the Earth's past, right? And I guess you piece them together a little bit like a detective and triangulate and try to form an image of what was it like, what was the Earth like. And of course, the Netflix documentary is great because you have all these graphics people that try to draw it. And I guess there's also a lot of, stuff that you just don't know how it happened. So they look at, for instance, they have this scene about how Tyrannosaurus Rex interact with each other, and of course they don't know if that's exactly how they did it, but they just
with the little kids, right?
The baby. Exactly. Yeah. So they just look at. That's also great. The what the documentary does is there are certain patterns about this competition between predators and prey or mammals, and so it's nice to see these patterns as well. But my question is like, okay, so if we are now in 2023, and I guess the field is not that old, right? And especially the technology is also evolving very rapidly. You can do things with computers that we couldn't do 10 years ago, and of course that is likely to increase. Do you think there will be a time when we know pretty much everything about the Earth's past, theoretically? Or are there maybe even certain time periods that you think, we just cannot, by definition, we cannot know anything about that because all the records from that period are lost? I'm not talking about inventing time travel or something like that, but with the current instruments where we can only examine rocks and leaves and all these things that we find now.
There's always some things you cannot know. If something happened yesterday, detectives might be busy for 10 years from now to try to solve the murder case. That's exactly the same for paleo history. There's a lot of things you can know, but there's a lot of things you cannot know. For example, how many documentaries on dinosaurs have the size of the moon, right? Have you ever thought about the moon actually being closer to Earth, or maybe farther away from Earth, but at least different than today? But probably not, because it's not in the documentaries. You haven't seen it yet. You might have read about it, but you haven't seen it. So there's always these little details that you don't even know if they're relevant or not. And that's what I said earlier. You never know the full picture if you don't see the full picture. So there's lines you can draw, but you cannot be sure. And that's also part of the philosophy of knowing, right? But to be more precise in answering your question, there are some parts of geological history that have been more degraded than other parts. For example, in Scandinavia, large part of the geological record have been wiped out by the glaciers that have been eroding the layers of the earth below the glacier, right? So some things have literally been erased. Or a better example is the parts of the ocean floor that have been reabsorbed by the Earth mantle.
I guess it's the same planet that recycle. I mean, the planet is a good example for us in terms of recycling and how do you say that? Upcycling and everything, right?
So there's a lot of parts of the planet that we can still trace back to the beginning of the planet, but most of it has been gone. So the farther back you go, the smaller your lens gets. That's a certain true. Yeah.
But could it be theoretically that, I mean, I understand, of course, yeah, details has another meaning, right? Because if you say a very short time scale and then you're thinking about millions of years, of course. But
the resolution.
Let's take, for instance, like maybe not the dinosaurs because that is very long, but that was like a whole dynasty. Could it be that there has been a dynasty on Earth that we just have no idea about, and that maybe later we find out that there has been something like the dinosaurs maybe very long ago?
Well, yes and no, because the story of life on Earth has very few hard missing links. So there's not a lot of places in our understanding of how life evolved on Earth where we say, well, we don't know how it gets from B to C at this point. We have this missing thing. There's not a lot of those. There are there, of course, missing links always somewhere, but it's not like we don't have a clue what happened between this point and that point. There are some events like the Cambrian explosion, where at this explosion, which is the opposite of a mass extinction, by the way, where you have all of a sudden have all kinds of life and it radiates. That's another term for it. The biodiversity radiates all kinds of different life forms. Everything's happening. That's the inverse of a mass extinction. So we don't really know what's happening there, and we don't have a lot of clues how that happened. But it could very well be that we miss entire parts of our history of life, as we have with our own history, right? So, for example, what we call as being the Dark Ages, which is a faulty term, but we have this term for the Dark Ages. We don't really know what happened exactly in the Netherlands between when the Romans left and when we get this Carolingian Empire. So that's roughly 400 years of things we don't exactly know, because before the Romans we know almost literally the price of bread per year, and from the Carolingian Empire onwards we start to write down things again and get a grip again. So there's a lot of uncertainties. What happens between the Frisians, the Franks, the Saxons, all in these wetlands that we now call the Netherlands. So there's a lot of blind spots, and there's a lot of possibilities of well, I'm not trying to get into extremes like what they also propose, like these lost civilizations. I mean, it's possible because you could completely erase a lot of findings, but I think there's enough blind spots. There's always more blind spots than we could know things in the fossil record. Absolutely.
Yeah. So this was still part of the first question.
Sorry, I forgot your second question.
No, I didn't. No, sorry. I said because I asked 2 questions already, but I said the second question was part of the first question.
Oh, okay. In that
anyway,
way, yeah.
So which means I get to ask you one more question.
Let's go.
Yeah, just whatever you want to say about that, because one of the things that I find interesting about you is that you are deep into this climate biology, but you're also interested in philosophy. And just whatever you can say about how do you use philosophy in your work, or how do you see the relationship between these two fields?
For me, being a scientist means being a philosopher too. True science happens on the boundaries of the unknown. That's where it gets very useful to know about knowing. So how to deal with perception, how to deal with the unknown. In specific case of paleoclimatology, there are many unknowns, whilst the lens you have is very small sometimes. So you have to be sure I kind of covered that also but in what you can assume, what you know, the known knowns, the known unknowns, the unknown unknowns, right? That science philosophy, I really like that. I also like other fields of philosophy, like rhetorics or ethics, specifically. So for me, being a philosopher is being a scientist, and being a scientist is being a philosopher. Yeah, that for me, that's really intertwined.
Right. So you don't see it as a separate field, but it's just fundamental for maybe especially your field, where you really have to think about what are the limits of knowledge, what we can know. We talked a little bit about, what are the basically ethics? What should we do? Okay, with scientific findings, what implications do they have?
Yeah, because nowadays it's so easy to form a narrative based on very few facts and walk away with it, run away with it, do everything you can with it, and forgetting what the actual facts are. And as a philosopher, I'm really annoyed by this behavior, and I just can't stand these unfactual movements.
Well, thank you so much for this conversation.
Well, thank you for having me. I really enjoyed it.